for your valuable feedbacks. Like previous day, I will post the feedback form in the chat box. Kindly submit your attendance and feedback form without fail. And in today's session, we will discuss about what is BIM, detailed workflow of BIM, BIM technology providers and tools. I think we will begin now. I would like to invite our mentor, Ms. Seena, our technical engineer, to lead the session. Ma'am, please.
Thank you, Shilpa. Good afternoon once again. Welcome to our third day session in Bridging Academy to Aeco Industry program. I'm Seena, working as Senior Technical Engineer in BIMLABS Engineering Services Private Limited. From the yesterday's session, I hope now you already have an idea about what is BIM and what are its advantages over traditional techniques, why to choose BIM, about LOD, maturity levels, etc. In our today's session, I'm going to talk about BIM cycle. That is, its workflow in eco industry. Now, you are familiar that BIM is actually a process, technology, or a workflow. If you are a person who likes to adopt new technologies or is passionate about your career, you must know about BIM. It is the future of the construction industry, or more clarity, not future, but present. Here you can see the BIM life cycle in eco industry. First, I like to give you a brief about this. These are the construction stages in a building, starting from programming. Actually, here the stage. Actually, it's an idea development stage. After getting idea about our building, you can discuss these ideas with an architect. That architect create a conceptual design for you. After confirming the conceptual design by the owner, can move to detailed design stage. In a commercial purpose building, we can see mainly 5 detailed designs, that is architecture, structure, mechanical, electrical, and plumbing. These are the major detailed designs in a building. The next stage is analysis. Various analysis will executed with the model and design will be optimized. In BIM, we can do not only structural analysis, but also energy analysis, coordination checks, clash detection, lighting analysis, solar analysis, etc. After the analysis, the design model will be updated with design data as per the design codes. Next stage after analysis is documentation. BIM documentation is fundamental to BIM, is needed to various stages with the project life cycle. Preparation of approval drawing, shop drawings, as-built drawings, etc. are some examples of drawings we need to do in this stage. Next stage is fabrication. In structural basis, we have steel detailing. In MEP basis, duct fabrication. That's the fabrication process. Next stage after fabrication is construction 4D and 5D. That's time management and cost estimation. Then next stage after construction 4D, 5D is construction logistics. For the smooth functioning of the project, all the resources should be delivered on time, or managing all these things related to this, we can have the stage. Next stage is operation and maintenance. Actually, that's a facility management area. We must service all the electrical equipments and building elements in right time. Service is better than repair. This we can increase the life of building. If we need to demolish the building, still we have the data. We can make use of the this for many things, because not only construction but destruction is also a form of engineering. Or if you want to renovate your project, the cycle will repeat from the programming stage. Okay, here is a BIM cycle video. Hello, is this audible?
No.
Okay. Actually, this is the just an intro of a BIM. Then we'll deal with conceptual design. Suppose if your person need to do a project on a shopping mall or something like that, the first person he go to meet is an architect, the one who has an initial contact with the owner, architects will initiate the design process with conceptual sketch or model. The client will be having a lot of ideas, requirements, concerns, and dreams about his project, like about how many number of stories required, balcony, about parking space, what are the floor area, because it depends on the building tax. Then total time duration going to take the project completion. Will it be within the planned budget, about occupancy, etc. He will try to convey this to architect, and it return architect need to produce an initial design that to place the client. This must be completed in a short period of time and can be called as conceptual design. Architect's design will also have a visual aesthetics. In BIM, conceptual model can be easily generated by conceptual modeling tools. Preliminary analysis like sun or shadow, then lighting, energy analysis can be done using these tools. After the client confirmation, this data can be shared with a detailed design team for design development. For conceptual design, we can use tools like SketchUp, Formit, BricsCAD, etc. These are many advantages to using Formit over SketchUp. Formit provides real-time collaboration, energy analysis, solar analysis, Autodesk materials, and it can be also utilize Dynamo to aid in design decisions. In Formit, we can use correct location of proposed building that helps to do conceptual level energy analysis. We can use sun path of that particular building with the help of building location for conceptual shadow analysis. The end result is we can simply find out where is the overheated area in that proposed building. Then we can provide solar panels to that area. Also, Formit can be directly sent into BIM authoring tools for preparing detailed designs. Next one is programming. We can generate complex building components with basic programming technique. Programming is a part of modeling where complex design can be achieved by programming and visual programming tools. If my project is having some complex design portion, suppose the front elevation of my project is in wave shaped form or something like that, when we plan to model that particular area by using normal modeling technique, that will be little more difficult. The design team will definitely face some issue while modeling. If the designers using BIM technology, they have a perfect solution, that is parametric design. Actually, parametric design is a process based on algorithmic thinking that enables the expression of parameters and rules that together define, encode, and clarify the relationship between design intent and design response. It makes the design process easier to finalize. Then repetitive tasks can be easily managed by programming techniques. It's an advanced technique in BIM workflow, having a lot of opportunities and scopes. Python language can easily connect with these tools. Then we have a lot of parametric tools in the industry. These are the major parametric design tools. If consider Grasshopper 3D, Grasshopper is a visual programming language and environment that runs with the Rhino 3D CAD application. Dynamo is also another visual programming tool. It enables designers to create visual logic so they can explore a wide range of parametric conceptual design using logic. In my project, if the design team wants to model remaining portion of my building using Autodesk tools, then they can use Dynamo for the complex wall creation. Then remaining tools are generative components, a modeler, SketchUp plugin. Actually, the SketchUp plugin is for parametric urban design. It is implemented as a plugin for Trimble SketchUp. Then Marionette, Vectorworks. These are the major parametric design tools. Then detailed design. After completing the conceptual model, the design team will present the conceptual model to client. If owner is confirmed the conceptual model, then we can simply move to detailed design. I'll show some conceptual model. Okay. It's actually a image of a tree house. That's a design of a tropical island resort designed by Pacific Environment Architects Limited. In this model, this model have 3 wings module as illustrated. It's a perfect example for a conceptual design. In every multi-story building have 5 number of detailed design. In my project have also the 5 number of detailed design, that is architecture model. In my project have common brick wall, doors, windows, ceiling with light, interior design part, then rendered image, detailed architecture estimation, etc. In structural model, then tell me what are the structural elements of a project, of a construction? Just please enter in the chat box. What are the structural elements? Do you know about structural elements? Yes. Column, beam, slab. Yes, correct. Yes. Foundation is right. Yeah. In my project have also a strong beam, column, footing, and also rebar. Suppose if my model have steel structure like columns, beams, braces, truss, stairs, handrails, joists, etc. If my building have centralized AC, that is HVAC system in the mechanical design. In my building also have electrical equipments, that is light, fan, switches, conduits, circuit wire, etc. That is an electrical design. Uh, in my building have also domestic water system. Details about sanitary fittings, fire alarm, these are in the plumbing design. If my building have any kind of plant like rainwater tank, biogas plant, that is in the plant model in the basis of detailed design. Okay. These are the major detailed design tools, that is Revit, ArchiCAD, Open Building, BricsCAD BIM, Vectorworks, Tekla Structures, then Dassault System. These are the products from different companies. Output of the product is same, that is detailed BIM model. Dassault System is a 3D experience company, provide business and people with virtual universe to imagine sustainable innovations. Various analysis will executed with the model and design will be calculated. Then I want to calculate how much load in my building, that is in the analysis stage. Analysis is the next stage after preparation of detailed design in BIM cycle. I have already said detailed design analysis are parallel working stages. That is when you plan to design a structural model, you must done the structural analysis. We know that structural model can not finalize without analysis. After just making our structural model, we have to send it into a structural analysis software from where we have to, depending upon the type of the building, we have to check what leads or what loads are going to come to the building, that is what that is dead load, live load, wind load, seismic load, etc. We have to analysis whether our building is stable or it has sufficient strength. Otherwise we have to redesign it. Some more topics also in the analysis stage, that is cooling load calculation, energy analysis, lighting analysis, area analysis, clash and coordination testing, etc. All those we can be done by doing solar analysis. You will be getting in a heat exposure, whereas the maximum heat exposure will come. We can analyze these things. Then these are the major structural analysis tool, that is StatPro, ETABS, SAP, SAFE, Autodesk Robot Structural Analysis, ANSYS, Plaxis, RISA, Midas. Then if the designers plan to use Autodesk tools to modeling and analysis, then they can use Autodesk Revit for modeling and Autodesk Robot Structure for analysis. Then we want to calculate overall energy consumption and heat emission of my building. We can use some tools, that is Autodesk Green Building Studio, Autodesk Insight, Design Builder. I think, do you know about IGBC? Anyone know about IGBC? Can you please enter into chat box? IGBC. Anyone know? Okay. Yes. Yes. Correct. Indian Green Building Council. Correct answer. Okay. IGBC means Indian Green Building Council. It's a first rating program developed in India exclusively for the residential sector. When you plan to construct a building in BIM technology, that building must have energy efficiency, water efficiency, environmentally preferable building materials and specifications, waste reduction, toxic reduction, indoor air quality, smart growth, and sustainable development. Okay, after completing the designing part of my proposed building, we must have approval from government for construction. In the engineering process, we have to prepare a lot of documents. If it is the large scale building, we have to prepare 1,000 number of drawings. In BIM, if you are making any changes in the model, all the corresponding views will get automatically updated. At the time when you prepare documents, you can work in that documents to itself. When you do whatever changes making the particular view, the changes will affect all those views depends on that particular view. Example, elevations, sections, shop drawings, all the changes will have automatically. Now the design team complete all designs of my building. Then tell me, what are the major detailed designs of my building? Tell me, what are the major detailed designs in a commercial building? How many number of detailed design? I'm wait for your response. Anyone know? Okay. Okay. Actually, that's architecture design. Then anyone know? Okay, leave it. Actually, that is architecture model, structural model, mechanical, electrical, and plumbing. Okay. If the designers using to model is Revit as a tool, the output from the tool is intelligent 3D model, and also we get 2D drawings. We can use that 2D drawings for construction purpose. Actually, the main process of the documentation stage is preparation of approval drawing. Actually, this is used for approval from government. When we prepare an approval drawing, we must follow some rules. Actually, I'm from Kerala. That's why I used to follow Kerala municipality building rules for the preparation of approval drawing. At the design stage, they will produce 0 error output. Then we can prepare an approval drawing very easily. The next stage is preparation of shop drawings. Do you know about shop drawing? Okay, then tell me, what's the language of an engineer? Tell me, what's the language of an engineer? What is the language of an engineer? Yes, correct. Drawing. Yes, drawing is the language of an engineer, but normal ordinary laborers cannot understand the language of engineer's drawing. So we want to convert engineer's language drawing to normal laborer's language, that is shop drawing. Actually, this is for construction. After getting approval drawing from my project, I can go to corporation for building sanction. In my building must have detailed cost estimation report. That is also in the documentation process. These are the main documentation tools, that is AutoCAD, MicroStation, ZWCAD, BricsCAD. Then These are the major CAD softwares in the construction industry. Team members are in an office, they can use this software. Otherwise, we want to use cloud facilities for the documentation and review. That is, we can use BIM 360. That's a cloud application. So it shows in the video.
Traditional structural engineering workflows can involve a variety of challenges. Structural engineers typically start the design process by getting familiar with the architect's design, by interpreting architectural drawings or general 3D conceptions. Because the structural designer or engineer creates both the physical and the analytical model concurrently using Revit software, the data can be entered once and used for different purposes. In this example workflow, a structural designer creates the physical and analytical model and exchanges these designs with a structural engineer who runs analysis to check safety conditions and to perform optimization. Rather than working in siloed systems, they both can use BIM 360 docs. BIM 360 docs integrates the entire project workflow from design to construction across one common data platform. Structural designers can use the Publish Settings tool in Revit to select views and sheets of the model to publish them to the cloud. These selected views and sheets are automatically extracted in the BIM 360 docs environment to give extended teams easy and instant access to the project information via web or mobile. Then the extended team of structural engineers can easily review what has been done in Revit and the current state of the structural project. When project teams have the right information at the right time, work happens faster. BIM 360 docs lets them publish, manage, review, and approve all drawings, documents, and models, anytime, anywhere. The project teams can not only review all information, but they can also download project files. With access to the project data, a structural engineer continues the design process by performing structural analysis and running code checking optimization. The Revit analytical model can be sent to Robot Structural Analysis Professional with all the information needed for structural analysis, including boundary conditions and loads. In some cases, the engineer may also decide to make changes to the model prior to analysis, based on their experience or access to advanced simulation tools. For example, the wind load simulation feature lets users simulate wind flow around a structure and generates wind loads automatically. Once the analysis has been conducted, the engineer can easily explore the results and begin designing structural elements. Robot Structural Analysis Professional is a powerful tool, not only for calculations, but also for visually exploring results. With multiple ways of presenting analytical results and the ability to easily access them, structural engineers can very quickly prepare the final structural documentation for review by project stakeholders. Next, the structural engineer can run code checking of the structure to verify and design steel members based on a wide variety of national and international codes. The first step in designing structural steel is to organize the bar elements, beams, columns, braces, etc., into member groups. Each member in a group will be assigned the same section by the design process. The engineer can also select optimization criteria. Once the design group is optimized, a simple Change All button allows all new sections to be applied to the model. When design changes and analysis have been completed by the engineer, the information can be brought back into BIM 360 docs to allow the designer to review the design changes and update the physical model accordingly. Here, structural engineers can upload their structural analysis and code checking documentation in the PDF file format. Results can be easily stored and explored in the Revit environment, enabling users to explore and document results and make effective design decisions. Once the Revit model has been updated after the analysis and code checking process, the structural engineer can upload a new version of the Revit project to BIM 360 docs. Then the structural designer can access the updated optimized model by the structural engineer via BIM 360 docs. Using the Compare tool, the structural designer can get insight into what has been changed in the model. BIM 360 docs has integrated change visualization that lets users compare the changes between two selected versions of the project. This summary provides a quick overview of changes made by the structural engineer during the code checking process. With BIM 360 docs, structural teams can manage 2D plans, 3D BIM models, and any other project documents. This streamlines the connection between design and fabrication.
Okay.
Traditional structural
In a building, they have a prefabricated elements. Actually, fabrication process is the construction industry is in civil bases, bar bending, window, door, steel members, and staircase, etc. In mechanical basis, a fabrication of that. That's typically made offsite to the specification required for the project. For generating the code for the prefabrication, we can use BIM. In structural basis, we can use Tekla, PowerFab, then Advanced Steel, SDS2, Bentley Pro Steel for the structural fabrication. For MEP fabrication, we can use Autodesk fabrication, CAM deck, estimation MEP, CAD MEP, etc. Then come to construction 4D and 5D. That means the time simulation and cost estimation. We are having project management team. They have to plan accordingly, like when we start the project, listing of the activities to complete the project, and by connecting in an effective manner. So the project output will be completed. The overall project duration will be like this. While selecting every task, we will be getting the cost of the project and the time duration to completing that. Construction 5D means cost estimation. Actually, we can do model-based cost estimation. That means after having a BIM model, you can directly extract the quantity takeoff. There will be directly getting the cost data for quick what quantity takeoff, and also we can generate virtual pre-construction video for the presentation purpose. Actually, my project is a perfect BIM model, so my model have also time schedule and budget estimation. If my building having effective material management and property distributing resources, it reduces cost and saves time. After completing the design stage, output of the design stage is 5 different detail models. So we want to coordinate that models. Actually, this is an image of a coordinated model. This coordinated model have structural element, that is a beam column, footing elements, then electrical, mechanical, and plumbing design. After design coordination process, we can find out model clashes and we can simply resolve that clashes in design stage. I'll show one model clash image. Okay. It's actually an image from a project review software. In this image, highlighted 2 elements. That is, one is green color, second one is red color. These 2 elements that are intersect each other. This is a clash. We can find all model clashes from design stage, and also we can resolve the clash. That's why the output of the BIM design is called zero error 3D intelligent model. Then these are the major construction management and review software, that is Autodesk BIM 360, VCOffice, Autodesk Navisworks Manage, Synchro, Bexel Manage, Solibri, then Bentley ProjectWise. Then construction logistics means this is actually for the smooth functioning of my project. Actually, BIM works in a collaborating platform. The main advantage of BIM is every project members can have a connection between each other, no matter where they are. That means anytime, anywhere access between the project team member. If my project team have a member that my team members are in a different place. I think, for example, architects in India, MEP engineers in Singapore, etc. We can maintain a connection. Team members in everywhere. If I have in that project team, I can share the project. Then the team members can review, upload, modify, etc. They can work with me simultaneously within a cloud-based platform, no matter where they are. Facility management can be defined as the tool and service that support the functionality, safety, and sustainability of buildings, grounds, infrastructure, and real estate. In my building must have a facility manager. The main duty of this facility manager is security. Then maintenance and service all the work facilities to ensure that they meet the needs of the organization and its employees. Commissioning refers to the process of bridging an item into operation and ensure that is in a good working order. In BIM 360 app, once we just use offered by Autodesk for having the cloud-based services. As you know, construction dimension up to 6D, 70 construction means operation and maintenance. Actually, BIM is very useful to the owner. Apart from every stakeholder, they have benefits, but most is for the owner. Operation and maintenance, most requirements for owner, because it's very essential for the increasing life of the building. And what it helps is that's operation in BIM. Facility manager have a role in initial stage itself. They can communicate with the design engineers. We can calculate life cycle of my building. How long can it last when these electrical and all building elements will service? We can generate all the details about the building from the BIM model. Actually, it's a video.
The future of project delivery has arrived. And it's here with a common data platform to ensure seamless transitions as projects move from design through planning to construction and operations. All project data is collected in a common data platform, ensuring accuracy and availability of information, and reducing data loss across phases. BIM 360 facilitates a frictionless data flow with Autodesk authoring tools. As an open platform, you can leverage information from third-party applications using Forge APIs. This centralized data allows you to extract insights that lead to better predictability. Data-driven decisions replace last known information and lead to avoidance of unforeseen problems, both for individual projects and across your portfolio. In BIM 360, all teams and data across the project lifecycle are connected, automatically processing industry-standard file types to enable seamless access and coordination across distributed teams. Design teams can co-author models in controlled work-sharing environments by managing permissions and allowing work-in-progress development prior to publishing. Teams can easily understand changes as the project progresses through change visualization in an aggregated viewing environment, while coordinating deliverables across the entire project team. Sharing design data with contractors and fabricators facilitates better planning and coordination, while reducing the likelihood of RFIs and change orders, lowering costs and keeping the project on schedule. And adding in data from pre-construction software will define scope, quantities, cost, and schedule with all of the available information. As the project moves to the job site, contractors and trades are able to harness critical information in real time, mitigating risks that typically occur once construction begins. Utilizing the most current project information, centralized and available in a common data platform, multiple firms are able to access exactly what they need, when they need it, and in the format required. And with the BIM 360 platform, all building and design information is available to owners and facilities managers. BIM 360 is where you connect teams across project phases, centralize data to ensure accuracy and access, control information from conception through operations, and analyze data to gain insights and increase efficiencies. Here in the Common Data Platform is where you deliver the right information in the right format to the right person at the right time to improve collaboration and coordination across the entire project lifecycle. This is BIM 360, the future of project delivery.
Then demolition. If you need to demolish the building, still we have the data. I have already said we can make use of this for many things, because not only construction but destruction is also a form of engineering. If I want to increase the property value, or my building is too old, then I can demolish my building. The word demolish means destruction, breaking down, or removal. Actually, BIM offers effective construction and demolition. It have quantitative waste prediction, and BIM allows multidisciplinary information through the BIM model and integrate the information of detailed waste estimation and planning. And we can be planned waste recycling and reuse, and pick up truck requirements and waste disposal charges fee for different waste facilities will also be predicted. Actually, this is a demolition done in Kerala last year due to unauthorized construction. Look at the video. It's actually a video for about demolition. Then next stage in the BIM cycle is renovation. Suppose if you want to construct an extra block in your project, you can renovate. In BIM cycle, we have renovation process. In BIM, we have a lot of digital technologies available for renovation. Most of them are used to renovate any kind of historical building or something like that. They can use 3D laser scanning technology. In that technology, will easily help to take the first steps to obtain and generate an the modern digital toolset accelerate the process, providing the required deliverable for the project. 3D model that was taking using the 3D laser scanning, and normally these models are given as an industry foundation classes, that means IFC. That files can be imported into any design program that is compliant with the standard to help to easy industry. Then in this video, I want to show you what's the output of 3D laser scanning technology, and how can we convert existing building data into perfect BIM model. Can be actually this can be used for renovation.
If you would like to learn more about what point cloud exactly is, please click on this video. If you'd like to learn how.
Okay, we can extract views like floor plans, elevations, sections from the BIM model. That means scan to BIM model. The most of them have confused about the renovation process by using the 3D laser scanning method. That's called scan to BIM. Suppose if you want to renovate a historical building or something like, for example, we want to renovate our Indian Parliament building, we can use this method. That is scan to BIM. Another example is we can consider a palace. Now the managing team of that palace is, of course, that government. They didn't demolish that building. They plan to renovate day by day. Actually, that's saves for our next generation. I'm going to take Padmanabhapuram Palace as an example. Now, the palace was badly damaged. The Tamil Nadu government planned to renovate day by day. For that renovation process, we can use scan to BIM as a technology. Scan to BIM brings the documentation of existing building into line with BIM. The primary method of scan to BIM is to use 3D laser scanner to capture a high density point cloud of a physical building, structure or site, which leads to the creation and maintenance of a BIM model that reflects as is condition. Application for models made using scan to BIM can range from as-built documentation, project renovation and additions, or even facility management. Okay, in this video, I want to show you what are the different steps in scan to BIM process. Okay. Actually, these are the major benefits of BIM for renovation projects. It enhanced the information exchange and added document control, including sharing model, meeting minutes, project images, etc. It have the ability to share data across applications. It elimination of unbudgeted changes on projects. Its cost estimation accordingly to within 3%. It avoid potential requirement of redesign. It reduces the in project delivery time. We can reuse and remodel instead of building new. And these are the major benefits of BIM for renovation project. To keep it well in mind, I'm going to show you BIM cycle once again. The cycle starts from programming, then conceptual design, detailed design, analysis, documentation, fabrication, construction 4D, 5D, construction logistics, operation and maintenance. When in the life of the building, you can demolish. Otherwise, you can renovate. The cycle will continue. BIM is not a software; it's a collaborative technology in Aeco industry. In tomorrow's session, we'll deal with BIM outsourcing companies and its case studies, challenges, etc. It may useful to your career and understood BIM projects all over the world. Don't miss the session. Then, if you have any query, please send the chat box. Thank you.
Thank you, Zainab.
Otherwise,
okay, anything else?
Okay, nothing.
Okay, fine. Okay, I hope all you have filled the feedback. If not, please submit. The feedback link is in the chat box. Okay, I would like to express my gratitude to all the participants for their presence and contribution. Thank you once again. So let's meet tomorrow at 3 p.m. Thank you.